Hello friends, we are starting with another part of this series, that is SaaS software as a service and distributed version control systems. In this we'll see how Facebook do its testing, means Facebook testing, and then we'll see GitHub and GitLFS. So we are starting with the SaaS and Facebook testing with Infern and Spinach. So scalable Facebook testing was there. In the Facebook, there's a scalable testing approach happens because there are large number of users of the Facebook was there. So replicating those large number of users and demonstrating and just providing illusion of those thousands and millions of users should be there for just mocking purpose of testing. Then this requires scalability. So scalability is different for different techniques and different persons. So it depends on whether that scalability is fail or been successful. So in different dimensions was there for scalability, memory, processing, etc. So it depends on whether it was successful or not. Then the scalability also needs some degree of deployment, that how much deployment could be possible on one machine, two machine, three machine. So this is the way actually the scalability works. Then challenge and opportunity was doing in testing as well. So there are two type of fundamental testing ways: static analysis and dynamic analysis, and both required to be done at scale when you are talking about millions of users. Then Facebook actually deploys two type of technologies. One is Infern for static analysis and second one is Spinach for dynamic analysis. And both were started from as a startup, and then it was being hired by or acquired by Facebook. And this is actually been impacting millions of people working together, and this is resulting in subsequent deployment of scalability. Then infer is basically static analysis at a scale. Means infer is helps in doing deep static analysis tool, which actually can test Java based code, Object C, C++. So this type of code base could be statically analyzed with the infer. So Infer was been acquired by Facebook in 2013, and the startup name was Monoidic. Then Infer is an open source and it has been used by several companies like Amazon Web Service, Mozilla, JD.com, Spotify. Then the Infer is based upon separation logic, which is having a scalable approach for doing state transfer. How the state transfer will help? It helps in doing storage and heap management, and how the memory of the heap and storage was working, so testing all these things. Then it also helps you to do automatic stack allocation variable analysis, then dynamic allocation of those memories analysis. All these things are being supported by Infer. Then it for also helps to do implementation compositional analysis of programs like interprocedural analysis, where two, three, four procedure are interacting with each other. So change in one operation could be analyzed for the change required in other operations or procedure. So this type of interprocedural analysis was there inside Infer. And then it's like a pointer chain. So in the C programming, so pointer chain was there, means three, four pointers are embedded together. So doing safety analysis for these programs. Then scalability to the large code base was also being supported by Infer. So result was like 10 thousands of bugs in Facebook was being discovered by Infer and been corrected by the Facebook developer before the production. Then next we'll see Infer static analysis in detail. So Facebook actually practices continuous development and deployment because it is a live real-time website being used by millions of users at a time. Thus, Facebook continuously integrate the development and keep on checking on the differences, means diff of code change happening in the backend. This require code review. So the developer actually shares single code base to alter and commit over the code base, and then it prepares difference for and submit it for the code review. How the infer actually runs. The developer actually shares multiple codes at a single repository, and developer keep on altering and committing over the code base, and then they actually prepares for the difference, and then they continuously submit the code reviews. So the infer actually run as a bot and work during the time differencing, that diff time means when the code changes were being done and how the diff things were working. Infer actually provides some writable comment for helping developer and other human reviewers, and it actually works before the post land, which means deployment and the runtime testing part, means dynamic testing part, you can say. So this is infer static analysis. Next, we'll see Spinach dynamic analysis at scale. So Spinach is deployed and run continuously for testing some of the recent developments happening at the Facebook, and internal building was there. So Spinach is multi-objected automated test case design system, and where you see the maximization of fault relevance, which actually minimize the debugging effort to fix those errors. Then the Spinach uses two type of Facebook utilities: FBLearner, which is a machine learning infrastructure of Facebook, and Facebook's OneWorld platform. Then how the FB Learner works for the Spinach. The FB Learner means Facebook machine learning infrastructure was actually a machine learning platform which works at the large scale and which is having many machine learning utilities and which runs at the real time for the tens of trillions per day. So you can have a large scale machine learning platform and which actually supports global scale, means large amount of scale it supports. It's having Spinach running as one of the service. There are hundreds of services being supported by FB Learner, and Spinach is one out of those hundreds of services deployed at Facebook Learner framework. Then FBLearner actually have a flow component in Spinach where you have a deployment or detection purpose, and it actually supports the crash. If the crash happens at a particular time, then it actually supports integration of fabricator for reporting and action fixing the things. These are the parts of which was being aligned with the FBLearner and Spinach. Then Spinach and FBLearner both autocorrect the failure and detect the failure and autocorrect it. So these are the three features which were being done by both together, Spinach Learner and FBLearner. And then the Facebook One World platform. What is Facebook One World platform? It is like a supporting scalable deployment of many emulators, means thousands of emulator working together, and it is like virtual or imaginary users working together for testing purpose at a single time. Then the Spinach actually deploys thousands of such emulators for testing such Android app. It means you have hundreds or thousands of emulator working together for testing a particular app of Facebook. Next, we'll see FBLearner in detail because it is also related to scalability. It is like a machine learning as a service inside Facebook, and which is having three main parts. One is FBLearner feature store, which actually stores some feature for CPU processing, and then it do some training part, means FBLearner flow with the help of CPU and GPU both together. Then the model was being generated. Based upon that model, you can do predictions. FBLearner predictor works over here for doing inferences, and then the predictions would come out for various applications. So the FB Learner actually being leveraged as a product or service for various services at Facebook. So for example, there are different models of machine learning: support vector machine, gradient, multi-layer perceptron, convolution neural network, then RNN, recurrent neural network. So there are various services of Facebook being supported by this. So for example, SVN support Phaser, then Gradient supports Sigma, MLP multi-layer perceptron supports add new feeds, news feeds, search and Sigma, and then CNN's been supporting Luminous, Phaser, then RNN support text understanding, translation, speech recognition. Next, we'll see Facebook's OneWorld platform in detail. So this is how the emulator works, and it supports communication of imaginary ABDs, means Android debugging bridges, and actually having illusion for the many remote devices working together and testing the Facebook apps. So how it works? It has four main features. Runtime worker service. It actually manages lifetime of resource and responds according to the request of the client, and it actually creates illusion that there is a life cycle of resource requirement of a Facebook app, and then the client was requesting these feature and these resources. The next, One World Daemon. So in the One World Daemon, actually like GUI platform in front end type of thing, where the remote resources with protocol and communication could be managed, and you can have setup for worker or setup for the environment. And next, you have the scheduler, which uses Jupyter as for job scheduling services at Facebook. This actually try to match or mimic the workers' resources and then provide some specific requirement for the usage of the client. Then you have satellite. Satellite basically connects local resources to the global one world deployment. So it's like a communication in between the client and one world, which is being fulfilled by satellite. In the figure you can see client request or for one world daemon, and then the Jupyter will actually interface in between the resource of runtime worker service, devices at lab, emulators and satellite, and then you'll get the response according to that. Next, we are going to see the Spinach workflow. So this is in detail Spinach workflow, where it uses various stage loggers and that actually stores at the DB, and static string analysis it does. So it all stored at the DB, and then with the DB it actually generate fitness extractor, means which is better and which is not. It also uses genetic algorithm type of thing for selection purpose or initializing some of the gene interpreter and doing testing for the test generation and test replay to. It has various test suite according to which this whole. It also uses genetic algorithm for having better feature and better generation of the report. Then the DB actually generates report, and which actually says that these are the feature being crashed, these are the feature being coverage report, and these are the replay videos. So how the things works in the backend of Spinach, we have seen this. It all been done at the source file or APKs. So in the instrument of APK, multi-level instrumenter or decompiler was there to read the source and APK initially, and then the static string start analysis with the help of DB database storage, and then state logger start working, and then reports are being generated based upon the fitness functions and the test suits, and then the reports are being came up with the report of crash coverage on replay. Next, we are going to see the SAS and distributed version control system.